Let me start by showing you once again what Mathalgodb actually is. It is a database that adheres to a very clear structure that is defined in an ontology. It holds objects and their relations. And to give you a very short overview of that, let's go to the visual representation. Okay, and this is a very short overview. So the large circles, the large balls stand for objects, and the lines between them are the possible relations. So let's zoom into one of these. So you see that algorithms are at the center of everything, and that we have publications connected to them that study them, invent them, and so on. And additionally, we have realizations, which could be software or benchmarks. So more or less, our graph represents algorithms and their documentation and their realization in software and benchmarks. Okay, so let me give you a very short idea of how we can use that. And let's go to a very practical use case. Let's assume I'm a mathematician who is quite aware of partial differential equations, but doesn't know too much about model reduction. But you've heard about the POD method and maybe you want to implement it, or you just want to try it and use an available implementation. So let's take that as a use case. And while I could just search for POD methods here in the graph, let me try something else. And let's go for a graph query, which more or less which better shows you what kind of questions you can actually answer using the graph. So we are in the field of model order reduction. I'm looking for an implementation, so I'm looking for software that implements the POD method. And while I already see it here, let me search for it, because that shows me all my options. So there are 3 algorithms actually available. Let's go for the first one here, and we find 3 implementations. So and just let me go back. So what are we looking at this point? It shows which software actually implements this particular POD method. I'm selecting one of these, and it gives me all the basic information, particularly what other algorithms are also implemented by this software. It gives me the identifier. It's located at software math, and it gives me some documentation on that software. The nice thing about this display is that it invites you to just play around with it. So now we are at this page. And we discover, okay, there are a lot of other algorithms also implemented here, and I might be interested in some of these. I might get interested in some of these. And for example, here for balanced gains, I find the corresponding documentation, I find the corresponding analysis, and also I find alternative implementations for this one. Okay, so to wrap this up, the interface that we have here allows you to play around with the data. It allows you to dive into the algorithms and just get similar things and so on. So this is something which I think is very nice. Since the graph is conceptually a user effort, we rely on users actually entering data here, on users from the community entering data into the graph. So when we had this creation procedure in mind, it was, for us, it was of the most importance that we make the process of entering data into the graph as simple as possible. And I think we did that. And I would like to show you that with, let's assume for the second user case that I'm an experienced mathematician, maybe I'm in tomography, and I find that a problem that is listed in the graph does not have the algorithm that I would usually use for that. So let's do that, and this time let's go for maybe seismic tomography. So I'm looking for seismic here, and the only problem related to seismic is seismic tomography, so I'll take that. And I find that actually no algorithm is listed here that solves it. So I would like to add one, and you see that there's a plus over here, and that's because I'm already logged in here as a Madi test user. However, we allow logins from all over GitHub. So I would like to add a property to seismic tomography, so I'll click on the plus. It takes me to the corresponding page, and I would like to add a relation. Seismic tomography is solved by a new algorithm, and so I could use one that's already there, but it's not there, so I'll add a new one. For the label, you see I already tried it. For the label, I will use common midpoint gather, which is a common algorithm for that. And it doesn't make too much sense to enter an algorithm without any reference. So let's give an analysis paper here, an analysis publication. And again, this is not an existing publication, but I would like to add a new one. And the DOI, I prepared a DOI here, so I will use this one. And you see that author and title are automatically fetched from doi.org, and an appropriate label is created. So I'll have to do nothing else but now submit this. Now, after submission, that entry is not directly available in the graph. It needs to be approved by someone who is an editor for the corresponding subject, so the subject here being tomography. So it happens that I am an editor myself. So I'll go to the dashboard, and here I see what I just did. I added a new algorithm, added or connected that algorithm to seismic tomography. I also added a new publication, which is really appropriate in this one, and of course the relation of the algorithm to that new publication. Of course, I want to accept that, so that's fine. I checked it, it's okay. I accept, submit, and now I'm done. Okay, so we would now expect that relation to be available in the graph. So let's go back to seismic tomography. And of course, now we find the algorithm listed here, and clicking on it, we find its data. It, of course, solves seismic tomography, and it's analyzed in the paper by Symes. So yeah, everything's done. And the quintessence, so what the take-home message from this is that entering something into the graph and also approving it is a process that's extremely simple and takes as little effort as at all possible.